Now that we have covered kind of a base overview of Seaborn functions as applied to the ASHRAE Thermal Comfort Database, let's dive into a notebook here that I've created called What Conditions Are Comfortable for People. And this notebook is going to try to put these visualization techniques in a little bit more of a context that could help you get a sense of how you could start to ask questions using the data set and using the functions you've learned from the Seaborn library. If you go ahead and clone this version or copy this into your own Kaggle account, what you'll end up with is a copy of it that you can execute the lines of code in the same way that you'll see here now. First step, obviously, is to load the libraries. Second step is to load the data set once again. If we take a look at the first 5 rows of the data set using the .head function, you'll see that this is the same data set that we've been working with. It gives you a sense of an overview of what we're looking at. And then, of course, the .info function will give that high-level overview of the 70 columns, what those columns are, and the number of rows, over 100,000 rows here. And you'll be able to see all the different metadata about these columns, including the number of non-null values. So get a sense of how complete each of the columns is. Just a kind of a review. And one of the things that we have done is we've looked previously at how to group the data using group by. We've used different columns for different things. And in this video, we're going to look at how to understand the concept of thermal sensation as a function of where the person actually is and what are some of the personal attributes of those people. Thermal sensation here is quite complete in terms of the amount of data. You have 104,000 non-null values, so it's almost the complete data set. And one of the things that we'd like to do is to create sort of whole numbers for things like metabolism and clothing, as well as the thermal sensation value itself. So try to round it up or down according to whole numbers. So for thermal sensation, it would be plus or minus 3 as well as 0. So 7 different points at 7-point scale. And what this allows us to do is to use these different columns as categories instead of as continuous variables, which you'll see in a second why that's interesting and important, but we use the .round function to do this. The first question we want to try to ask ourselves is, what are the conditions that influence people's comfort? This first thing we're going to look at air temperature, humidity, air movement, other things, and we're going to use box plots pretty exclusively in this analysis. As we go through, this is going to correlate closely with, or loosely with, some of the tasks that are included in this data set. This can provide a kind of a starting point for you to navigate and understand how to use the data set to answer the questions and the tasks for the ASHRAE Thermal Comfort Database too. The first visualization we're going to look at is a box plot. We're going to use the Seaborn library .box plot. The X variable is going to be the column thermal sensation rounded. The Y part of this visualization will be the air temperature. The data set, of course, is the IEQ data set that we've loaded. Since we have thermal sensation rounded, we're basically able to show, as you can see in the resulting visualization, -3 to +3. So very cold and very hot. And then basically everything in between, which is the thermal sensation that the participants in the data set felt when they were exposed to certain temperatures. Let's look at this chart. This is really a meaningful chart because it very clearly shows a relationship between the air temperature that the person was exposed to and the thermal sensation that they reported. 0 being thermally neutral, +1 being warm, 2 being like quite warm, and then 3 being very warm, and then vice versa for not -1, -2, and -3 for cold. So you can easily see here that, yeah, of course, people that say that they're cold are at a lower temperature, and people that say that they're hot are at a higher temperature. And the line here in the box plot in the middle is the mean of that. The outer edges of the box plot are the quantiles, 75th and 25th quantiles. The line at the end of each is the 95th and 0th, or 5th and 95th percentiles. So the ends of your range of most values, 95% of the value, or 90% of the values. And then the dots on the other side of the box plot are the kind of like the outliers. These are the plus or minus at the 5 and 95th percentile. And so you can see here that there is this trend from cold reporting to cold two are reporting very warm. However, there's quite a bit of diversity here. So you see these box plots are able to show that distribution of behavior. Human beings are not black and white in a sense that they always choose something the same, as other people have a diversity of opinions and subjective preference. And this really shows very clearly that's the case, essentially, that you have, for example, a thermally neutral. People are even saying that they're thermally neutral with very high temperatures and very low temperatures. And I think there's probably some error in here, because there's no way people are exposed to 60 degrees Celsius and felt comfortable. Probably some errors or outliers in there that are actually errors. Here you can see another plot where we've changed that Y variable to relative humidity. In this case, you can see that there's maybe a little bit of signal here, but looks like across the board, people are giving feedback basically the same across the humidity ranges. A little bit of difference in the ranges. Not to say that you wouldn't find a subset of data that does have relative humidity as a strong component, but as in the data set as a whole, it's not happening there. And then finally, let's look at a box plot using air velocity. And in this case, it's really difficult to see also because you've got an entire range of behavior and it all looks relatively similar. We could do some transformation to this plot to make it more easy to read. Maybe you do a logarithmic transform or something like that, but we won't do that here. We'll just take it as it is just to see what the data looks like in this respect. The next question we might want to ask is not just environmental conditions. What about personal attributes of the people in the study? We're going to try to use temperature because we saw that there is this correlation quite strongly. And we are going to, first we can see the .info, which we saw before. Now we're going to use an attribute in the dot box plot called hue. And in this case, we want to see if self-reported sex is a variable which influences thermal comfort. So male or female. So self-reported male or female sex as a piece of information. Here you can see that, and this is a hypothesis that a lot of people have, is with respect to whether men or women are feeling differently in similar temperatures, whether they feel too hot or too cold. And looking at the data, it seems that in general and across the entire data set, utilizing the box plot visualization, the story is relatively similar depending on which self-reported thermal sensation group you're looking at. For thermally neutral, it looks like males report thermally neutral at a slightly higher level than females. It's a very tiny difference. As you get warmer here, so slightly warm, men are saying slightly warm at a slightly higher temperature than women. And that changes it's at more warm, and then at very warm, it seems to go back to a similar level. If you go the other direction, females are reporting at the very other end of the spectrum, cold, very cold, at a higher temperature than men are. So this kind of maybe is a piece of evidence, let's say, that there is a difference between men and women. However, you have to take into account that this -3 is a thermal sensation, has a lot less data, let's say, than the other ones. And the box plot doesn't do a great job of showing that. There are other distribution visualizations which probably would do a better job of showing that, which you could play around and try out. So so that particular personal attribute is one thing we could look at. The other thing we could look at is other personal attributes such as age. So if we say .info, we can see that .age is one of those things. We could use age, but let's look at metabolism and clothing levels. So those are other personal characteristics of what the person is wearing, or what their metabolism levels are. Here is for MET or metabolism, where you have different levels. So 1 to 7, with 7 being much more vigorous than 1. And you can see that you also have the thermal sensation rounded from reporting sensation of very cold to very hot, the air temperatures there. And you can see that there are some differences. If we look at thermally neutral, for example, people with a higher metabolism are reporting that they're thermally neutral at a much lower temperature than maybe the other metabolism levels. So that's interesting. That's a piece of information that we could dive into deeper and explore with other types of visualizations, or potentially through the use of some sort of model to see if that is an important variable or a statistic What about clothing level? So let's look at the same type of chart with clothing level. And here you can really see some differentiation between what is the air temperature that people report being thermally neutral versus too hot or too cold. You can see very clearly people with a higher clothing level, especially once you get over 2.0, that they're reporting that they are cold or slightly cool or thermally neutral at much lower temperatures than people that are wearing less clothing, which is pretty intuitive in a sense, but here we have this quantification which really shows this. If you took a subset of the data and you looked at a certain region or location, you might find something different when you look at smaller amounts or subsets of the data. Here, let's look, okay, what can we look at in terms of the building or its systems and how they influence people's comfort? If we come down here in the data set, we can see that there are data points such as cooling strategy at the building level. You can see that there is fan, window, door, heater. So those are all characteristics of the building itself. Let's take a look at some of those. Let's look at, for example, building type as a variable. And this time we're going to make the plot horizontal. I like to do that often when you have long names here on the left that are quite long and you want to show them in that way. Here you can see according to building type across the whole data set that classrooms as an application are slightly cooler, let's say, according to the data set, than senior centers in this particular data set. So is this a characterization of classrooms versus senior centers and the wider building stock? Probably not, maybe not, but just specifically for the types of studies that are in this data set. And this is just an example of how to visualize the data in that way. The next one we look at is thermal sensation according to the cooling strategy of the building at the building level. So in this data set, you see like air conditioned buildings have a pretty normal range of thermal sensation from cold to hot, with the mean being right on thermal sensation of neutral or 0, which is pretty intuitive. Natural ventilation has a little bit here shifted to the right, meaning that on average in the studies, people were feeling a little bit warmer. Mixed mode as well. Mechanically ventilated seems quite close to air conditioning. If you, once again, drilled into specific subsets of the data, you may find different types of behavior. Let's look finally at thermal sensation as a function of season. Here you have summer, autumn, winter, and spring. The summer and spring studies are having a little slightly higher thermal sensations, a little bit warmer as compared to the autumn and winter studies. Let's look finally at which country someone is from and how that influences their comfort. These are going to be really big data sets of different kinds of cities and countries, big visualizations that I want to show. The first one is going to be a really longer visualization that I'm going to allow the visualization size to be quite bigger. But here you can see that each of the rows here on the left-hand side are countries. You'll notice that the thermal sensation rounded from cold to hot, and then based on down all the way here at the bottom, the air temperature, you can see that different studies from different countries have a lot of diversity. So for the studies in Mexico, you can see that people were exposed to a lot larger range of conditions, let's say, than a study in Italy. The study in Sweden, there's a pretty short, sort of constrained range of conditions as compared to Tunisia. This is just a really high level visualization. If you want to study this, you would need to dive in deeper and visualize the data in a more thoughtful way at the individual country level. And then you might design some individual experiments or something that try to understand why the differences are there, or quantify the differences, or create a metric, or really you have a lot of freedom to come up with cool ideas of how to show those differences. Now let's look at city. That's going to be pretty similar. It might be a little bit bigger of a visualization because there is quite a few more cities in the data set than there is countries. So this is the same type of thing that you can really dive into these individual situations, but you'll notice as you scroll, there's a wide range of behavior according to these studies. What if we look at climate? We have humid subtropical versus all the way down here to cold and cold semi-arid. So the same type of thing. You're seeing the visualization across this box plots according to thermal sensation. So this is just to show an example of how box plots can be used for that. This notebook is just to give you a sense of some of the visualization techniques to dissect this data set, to analyze what are the different features and contributions that different aspects of the data set have towards that thermal sensation value, just to give you a starting point for understanding how you might tackle the task related to these different aspects.